Hello everyone, you are welcome once again to my channel. Today we'll continue with our discussion of forces, and this time around we are looking at moments of a force. A force is able to cause a lot of effects on an object, like causing it to change shape, to accelerate, to change direction, to come to a stop. Well, another thing that a force can do is to even cause an object to turn about a point. The turning effect of a force is referred to as the moment of a force. And usually, a force is going to cause an object to turn about a particular point. The point about its turning takes place referred to as the pivot. So in our diagram, we see a depiction of what we are referring to when we talk about the moment of a force. Here we have a bar hinged at a point referred to as the pivot or the fulcrum, and we have a force acting on this bar from a distance d. The force is acting upwards, and so when this force is applied to this bar, it is going to cause the bar to move upwards, turning about this point referred to as the pivot. So we see two things at play here. A force is being applied to the bar, and it is acting at a distance d from the point about which turning is taking place. So then, what is moment if we are to define it mathematically? Mathematically, moment is referred to as the force times the perpendicular distance from the point about which it is turning. So moment is given as force times perpendicular distance. Now this is very significant because from our diagram we see that the force is perpendicular to the bar. It is not tilted at an angle or slanted. Two things affect the extent to which a force will be able to cause an object to turn. The magnitude of the force and the distance from which it is acting from the pivot can also affect the turning of this object. If we look at the force which is shown in red, this force is acting at a greater distance from the pivot. Because the force is acting at a greater distance from the pivot, it means that the force will be able to cause turning more easily about a pivot than for this force originally applied, because distance has increased. If these two forces are the same, then the extent to which this one can cause turning will be greater than the extent to which this one can cause turning about this pivot, because distance has increased. Supposing we have another force applied at this point here, this force is going to cause less turning because the distance at which it is acting from the pivot is smaller than the others. Distance has reduced, so more force would have to be applied to cause turning around it. Because moment is equal to force times perpendicular distance, if distance reduces, then it means that more force will have to be applied for turning to take place. Force is measured in Newton. Distance is measured in meter. Therefore, moment has a unit of Newton meter. Principle of moments. The principle of moment states that if an object is in equilibrium, the sum of clockwise moments about any point is equal to the sum of anti-clockwise moments about that point. So then if we have to take moments about a particular point, in which case it's going to be the pivot, the point about which turning is going to take place, then the principle states that if that object is in equilibrium, so we first need to understand what it means for an object to be in equilibrium. If an object is in equilibrium, then basically we mean that the object is balanced. What that means is the net force on that object is zero. the net turning effect or the torque on it is also 0. So forces acting on an object in equilibrium balance each other out, or the resultant force is 0. So if an object is in equilibrium, then the principle of movement states that the sum of clockwise movements about any point is equal to the sum of anti-clockwise movements about that point. In our diagram, we see a uniform bar. 4 forces are acting on the bar. We first want to pay attention to the downward forces. We have F1 and F2. F1 is acting at a distance D1 from the pivot. F2 is also acting at a distance D2 from the pivot. Now, if we assume that initially these were the only forces acting on it, F1 is acting downwards and it is causing turning about the pivot found in the middle. Turning or rotation is going to take place in this direction. When we talk about clockwise, what we mean is if you should take a clock, say a wall clock, and you look at the hand of the clock, it moves in this fashion. So this force F1 is going to cause turning about this point or in this direction, and so this one is going to be the clockwise movement. F2 is also acting downwards. It is causing turning about this pivot found in the middle. And so the turning effect is going to be in this direction, anti-clockwise. So our clockwise movement is going to be F1. Our anti-clockwise movement is going to be the force F2 causing turning about the pivot located in the middle. Now say we have 2 additional forces, F3 and F4, acting on this bar. Now F3 is acting at a distance D3 from the pivot, and F4 is acting at a distance D4 from the pivot. F3 is acting upwards, and if it should cause turning about this pivot located in the middle, then it is going to act in this direction to cause this object to move upwards. Then from our arrows, we can tell that F3 is acting anti-clockwise. F4 is going to cause it to move in this direction. So we have F3 and F2 acting anti-clockwise. F1 and F4 are acting in a clockwise fashion. So the principle says the sum of clockwise moments about any point will be equal to the sum of anti-clockwise moments about that point. So let's first write down the clockwise moments. So that is the sum of our clockwise moments. Now for the forces acting in the anti-clockwise fashion, so our anti-clockwise moments will be equal to F2 times D2 plus F3 times D3. Therefore, based on the principle of moments, we are going to equate the clockwise moments and the anti-clockwise moments. And that is going to give us, we are going to have F1 times D1 plus F4 times D4 is equal to F2 times D2 plus F3 times D3. Now, in questions involving moments, there are instances where you would have certain missing parameters. Say we don't know a force, or we have to find the distance at which a force is acting from the pivot. In that instance, it is important that you come back to this principle. It talks about an object in equilibrium. And we've established that if an object is in equilibrium, then it means that the net force on it is 0, or the forces are balanced. So then one thing you have to keep in mind is that using the principle of moments, we also say that the sum of forces in one direction will be equal to the sum of forces in the other direction. And especially for a problem involving a bar resting on a pivot like this, we are going to have the sum of the upward forces to be equal to the sum of downward forces. we'll have F3 plus F4 to be equal to F1 plus F2. And that gives us two equations. From these two equations, if there are missing parameters, we can use these two equations to be able to find them. Now, sometimes in questions involving moments, you can have two pivots acting, or it could be two forces acting from two different points, in which case those points are going to be the pivots. And you would be asked to find or solve questions involving that. So let me quickly run you through that particular instance to see how you are going to deal with a situation like that. So in this particular instance, we have two pivots on which the bar is resting. The pivots in this particular example are exerting a force on the bar, and these forces are acting upwards, F1 and F2. The weight of the bar is taken into account, and the weight is acting from the center. And that's please a point that you have to take note of. Once you are told that the weight of the bar is not negligible, for a uniform bar, we are going to have the weight acting from the center. The weight is going to act from the center of mass. How do you deal with a question like this? The question will typically not tell you where you should take the moments from. You can consider moments about this point or about that point. Now, if you are taking moment to be about this particular point, then what it means is that the force F1 that is acting here would have no moment because it is acting from the same point, and so distance is going to be 0. If distance is 0, then it means that moment will go to 0. If you are taking moment about this point, then what it means is that the force F2 would have no moment because its distance from this point is going to be 0 because it's acting at the same point. If we are taking moment about this particular pivot, because F2 is acting upwards and the pivot is at the left side of F2, it is going to cause turning in this direction about this point. So it is going to act in the anti-clockwise manner. The weight is acting downwards. The pivot is acting or is at the left of the weight, and so its turning is going to be in this direction towards the pivot. If we are to equate clockwise movements and anti-clockwise movements, then our relation will come down to clockwise movements W times C will be equal to the anti-clockwise movement F2 times D. I use this one as an example, the bar problem, for you to easily understand. But the same principle applies even when you have a complex problem. Take note of where your pivot is, where your forces are acting, and then determine the clockwise and anti-clockwise moments, and you can easily solve your problem once you know the distance from which they are acting. I hope you enjoyed this session. Thank you very much for watching. Please subscribe, comment, leave a like. You can also leave any questions in the comments. So thank you very much for watching, and see you in the next video.